Okay, so as always, do section A. These questions do not align to your test questions verbatim, but the content, the material tested, does align very well. So let's just make sure we go through each of these questions and you understand what you're doing. Right now, usually I would say just follow along with part A, but I want you to pause for a minute, do the questions in part A here. Then watch the video, see that you got them correct. The video will correct any mistakes that you have. Then go to part B, get that done, and then before you proceed to part C, show me part B, let me make sure you're doing it correctly, then go to part C. That applies for all the parts of the test. So, the first problem says to find f of -4. So what we're going to do is to plug in a -4, and I get 3 times -4, which is -12, minus another 4 is -16. Now it says g of 9, which is 2/3 times 9 plus 1. And this brings us to a very interesting point, because it seems to me that as soon as we have a fraction question, we're not getting them right. And if it was a matter of your understanding of fractions, I would be overly concerned, but it's not. It's simply a matter of how you use the calculator. Guys, listen, we've said this many, many, many times. We have to do it again. Here's how you input the stuff in the parenthesis, in the calculator. Parenthesis, 2 divided by 3, parenthesis, times 9 plus 1. 2/3 of 9 is 6 plus 1 is 7. So it's not a function of your intellect. It's a function of how you input this stuff into the calculator. The calculator does all of the work for you. Now, speaking of how you input stuff into the calculator, number 3 is the same way. What is the input on number 3? It's a -2. When I input anything into a calculator that's negative, it must be in parentheses. So when I put that -2 and square it into parentheses, or into a squaring function, I have to put it in parentheses. The reason is this. Look, I've said this before, but I really want to emphasize it. Number 1, or this 1 and 2, number 1 means square the 2, then negate it. This is -4. This is -2 times -2, which is +4. When I input a whole -2 and the function says to square the input, that means case 2 here. It means +4. And then I'm going to do +4 times -2 plus 5. So this becomes 4 plus 8 plus 5, which is better known as 17. J of 1, now we're getting into, in case you can't notice, the top case where we're squaring it after we negate it. So I'm going to square the 1. 1 squared is 1. Then I negate it, I get -1. Plus 2 times 1 is 2, so this works out to be +1. And then in number 3, we're trying to emphasize a similar idea, namely that you square it, then multiply by 3. It's all about the order of operations, and then I'm going to subtract 4. So if I square 1, I get 1. Then I got to multiply by 3, subtract 4. And 3 minus 4 is -1. Now, I would say that those skills and how to enter that data into the calculator, or do it in your head, which is even better, are critical for understanding work that we do throughout the year. And that's why you see it again on the Relearn packet, because you will trace some of the mistakes that you made on the current test to a lack of understanding of those questions on the prior test. All right, now number 2, which notation below is equivalent to 4 is less than, x is less than 7. Notice the symbols. Neither one of them has an equals under it. If I have either of these two, then it's a bracket. If I have these two, it's a parenthesis. So in this case, they both have to be parentheses. It's choice D. Number 3, Johnny climbs up to his roof and shoots a water-propelled rocket from a height of 25 feet. The rocket has an upward velocity of 57 feet per second. Write a quadratic function that can do this. First off, it's h of t equals t because of time, -16 t squared. And then the upward velocity is 57 feet per second. The upward velocity always goes next, plus 57t. And then the height from which it was shot, plus 25. Biggest mistake I see here is kids forgetting the negative in front of the 16. And I also see some kids forgetting the squared here. Those two things are the most common mistakes. Don't forget your t there. Those 3 things cover pretty much every mistake I ever see. Next, what's the axis of the symmetry of this function? There's two ways to get the axis of symmetry. By far the easiest way is to graph it in the calculator. When you graph it in the calculator, see the line that goes right down the middle of your parabola. Here's a parabola. Here's a line that goes right down the middle. The first thing you want to notice is that this is a vertical line. Vertical lines always begin x equals. And then it's going to be the line down the middle. Now in this case, it's going to be x equals -3. If you graph this guy, you will get x equals -3 as the line down the middle. You could also look in your table. If you look in the table, and you'll see a bunch of points, like, I'm just going to throw numbers out there because I don't know what they are off the top of my head. 3, -1, 0, -1, 0, 3, 7. But the bottom line is that you'll notice this point here in the middle is around the ones that pair up, around the ones that have symmetry. This point in the middle, the x coordinate, let's say that this was, like in this case, -3. That would mean when x is -3, you have your axis of symmetry. So that's another way to get axis of symmetry. Or you can look at the graph and see the line down the middle, where does it cross on the x-axis? In this case, it's x equals -3, I'm sorry. That is the correct axis of symmetry in this problem. Very easy. The calculator, again, will do the work for you. Okay. Oh, by the way, here are the choices. When you look at the choices, you can immediately cross A and B off of the list because there's no way it can be A or B because those are y equals. And then C and D are possible, and you can just look at which side of the axis the axis of symmetry is on. Next, the Petri dish contains population for bacteria. This is actually a little hint towards your next test because you'll have a question like this on there. Population doubles every hour. This is an exponential function because the population is doubling every hour. It's 2 to the x. An exponential function needs to look like that. So that's what you're looking for. Okay? All right, we had a pre-test that had these kind of questions on them, or on it, about domain. And it says officials in a town use the function C to analyze traffic patterns. C of n represents the rate of traffic through an intersection, blah, blah, blah. What could be an appropriate domain? Well, we're counting vehicles that go through an intersection. There's no way I'm going to have negative vehicles. There's no way I'm having a half a vehicle. Even though a Volt and a Prius and some of the smart cars are tiny, they still don't count as half a car. Can't have negatives, has to be choice 4. Those are only positive numbers that come through. Number 9, the picture below shows the input and output of a system, the amount of money Jenny saves in her bank account for Write the function rule. Well, this is a linear equation because everything's going up by 24s. That's a constant rate of change. That's an indication of linear. Linear means, or uses, y equals mx plus b. B is the y-intercept. It pairs up with 0. So I know b is 48, and I know that this, m is also known as slope, or the rate of change. So it's y equals 24x plus 48. That whole rate of change thing comes back a little later in the test to be very important, and so does the slope of that particular problem, so we'll check that out then. Next, the table below represents the function f. The equation that represents this function is, and then what I suggest you do is plug in your choices and see what you get. See which of these will explain what's going on. Like for instance, if x is 3, does f of x work out to be 9? So, for example here, does 3 to the third equal 9? I don't think so. I think that would be 27. 3x, well that's interesting because 3 times 3 is 9, so maybe 2 is the answer. Let's see if it works for 4 and 17. Does 3 times 4 equal 17? No. That's done. Let's try 2x plus 1. Let's try 2 to the third plus 1. What's 2 to the third? 8 plus 1 is 9. Oh, that might work. Let's try 2 to the fourth plus 1. 2 to the fourth is 16 plus 1 is 17. So far they both work. Let's try 6. 2 to the sixth is 64 plus 1 is 65. And it works for all the rest of them, so choice 3 is the correct answer on that one. Okay, next up, greatest rate of change. And now we're looking, rate of change is such an important big topic in this class. It says Jameson family kept a log of the distance they traveled during a trip, as represented below. During which interval was their average speed the greatest? Now, speed is the rate of change. Where is it greatest? It's going to be greatest whenever the slope or the rate of change is at its highest. So like this rate of change is pretty low. It's almost flat. So is this one. This is pretty high. This one here is highest. And if I do the rate of change, 110 minus 70, minus 40, it equals 70. Over 2 minus 1. And that works out to be a rate of change of 70. This one over here would be 350 minus 230, which is 120, but it's also over 2, so that's 60. 70 is clearly bigger, so it's choice 1. The first hour to the second hour, that's when the speed is the greatest. They cover 70 miles in an hour, if you will. And in the other case, they're covering 60 miles in an hour. Okay. Now, that covers all of the question A's for this particular topic. So now, what we want you to do is to make sure you did your A's correctly, and then go on and do section B. And then show me section B before you do C. I don't want to see C done already, because then I'm going to give you grief, because it's not the best way to learn. You want to make sure you're doing it the right way. All right, next section coming up.